Today's lesson is called Simple versus Compound Interest. Please start with the opening exercise. I would like you to pause the video, and when you're ready to check your answer, please resume. Okay, would you rather invest $10,000 principal for 3 years in option 1, 5% interest on principal only, option 2, 5% interest on the principal and accumulated interest? So which one would you want to choose if you're investing? So investing means you're putting money in and you're looking for your money to make more money. So you want to pick the option that's going to make you the most money. You should pick option 2. And the reason you want to pick that one is you will gain more money after year 1. Year 1, it's going to be the same for both because you have the same principal amount. But then in year 2, your number will be higher. If you pick option 2, you'll be taking a percentage of a larger number. Okay, so option 2, you gain more money after 1 year, and it's paid not only on principal, but the accumulated interest as well. All right, so let's look at example 1. Jack has $500 to invest. The bank offers an interest rate of 6% compounded annually. How much money will Jack have after 1 year? So we're going to calculate the interest first. Remember, it's I equals PRT. We want to know the interest when we know our principal is $500. Our rate was 6%. So I'm going to have to change the 6% to a decimal by taking and moving the decimal place 2 places to the left, which means I'll be putting 0.06 in for my rate. And my time is just 1 year. So if I multiply 500, 0.06, and 1, I get 30. So for my total, I have my principal plus my 30% interest, $30 interest, for a total of $530. Now this time with compounded, we have to look at our table a little differently than we did the year before. It says up here, compounded annually. That phrase implies that we are going to be making interest payments off of the year's total, including the interest that's already been accumulated. So if we were to continue to compound the interest, there's that phrase, on Jack's earning, complete the table to help us develop a formula that will model Jack's earnings after 2 years. So make a little star here. Remember that the interest will be earned from the total and not the initial investment. So let's underline that a couple times to stress that point and how it's different from simple interest. So after 1 year, we already knew it was $30 for a total of $530. Now this is where it's different. We now have to take $530 and multiply it by the 0.06 in order to figure out what it will be the next year. If I do that, I'm going to get $31.80, which brings my total now up to $561.80. Then I'm going to take $561.80 and multiply that by my 6%. That's going to give me 33.708. Now I know you're probably looking at me like, what? Interest is money, and I can't have more than 2 decimal places. But in order for us to see the accuracy of this, I'm going to use all of the decimal places. So that's going to give me a total of $595, 5.508. So then if I were to continue in this pattern, I won't make you write that all down, but you're going to continue in that pattern, you would then have 35.73048, which would give you a total of 631.23 848. Then if we did it again, we would have 37.8743088 for a total of 669.112788. And lastly, for year 6, we would have 40.14676,733 for a total of 709,259,561. Now, that just came from taking whatever the total was and taking 6% of it. Taking the previous year's total, taking 6% of it, just like you see over here on the right. Now, in order to find out what's going on, we first want to take and see if we have an adding pattern, because they are asking us in Part B to determine what type of sequence you see, and it's either arithmetic or geometric. Arithmetic, you're supposed to think adding, and you can tell by looking at those, we're not adding the same number every time. So that means we are seeing a geometric sequence. So if you think back to what we learned about geometric sequence, it has a common ratio. And in order to find the ratio, you have to take a term like 561.80 and put it over the term that came previous, 530. If you do that, you're going to get 1.06 that this is being multiplied by. And then we could do the same thing for 595.508 over 561.80. And you will get times 1.06 again. And that pattern happens the whole entire time. So now you can see why I wanted you to keep all the decimal place values. If you had rounded, that common ratio would not have presented itself. So now we know it's geometric and we have a common ratio of 1.06. Okay, now in Part C, it says write a formula for how Jack will earn after T years. So we're going to make a generic formula. So the first option, f of t, is to set it up like a geometric sequence. The first term is 530. Our common ratio is 1.06, and then we compensate for starting with the first term by doing t minus 1. Now, if we wanted to use the principal amount or initial value instead, we can do that. We can say f of t equals, our principal amount was 500, so that's our initial value. Our common ratio is still 1.06, but then instead of doing t minus 1, we do t because we're not starting with the first term, we're starting with what's across from 0. The general formula for compound interest is future value, that's what FV stands for, is the principal value times 1 plus the rate to the power of t. And you can see 1 plus the rate happened in our formula. 1 plus, our rate was 6% or 0.06. That showed up right here in our formula above. Let's now look at example 2. If you have $200 to invest for 10 years, would you rather invest your money in a bank that pays 7% simple interest or in a bank that pays 5% interest compounded annually? Is there anything you could change in the problem that would make you change your answer? So we're going to investigate by looking at both scenarios. Okay, now typically for simple interest, we would use I equals PRT. But we know that that's just going to give us the interest, and then we still have to add it to the principal. So I'm going to take care of that by writing a formula that will cover both of that. So I'll use S for simple interest. It's a function of time. I'm going to have to take the $200 plus the interest. To calculate the interest, that's where I'm going to use the PRT. So 200 for the principal, 0.07 for the rate, because remember it was 7%, and I need to move that 2 places to the left to make a decimal. So that's going to be 0.07, and then I'm doing that for 10 years. If I find out the value of 10, which I'm going to go back and erase that t, because we are finding 10, I find out that S of 10 is $340 using my calculator. Now, on the contrary, let's look at compounded annually. So I'll do C of T And I'll write the generic formula first. So I have 200 as my principal amount. Now remember, 1 plus the rate. So 1 plus the rate for our compounded annually is 5%. So 5%, move the decimal 2 to the left, would be 0.05. So 1.05 would be our common ratio, and then we would have that t. So we're going to find c of 10. I'm going to replace the t with 10. And I would end up with, if I use my calculator, 325.78. So if I'm looking at these two values and I have to decide where I want to put the money, I'm going to pick this one. It's more. So I would pick the simple interest bank rather than the compounded annually. Now the last part of the question says, is there anything you could change in the problem that would make you change your answer? Well, you know from previous examples, looking at the table, the longer I invest, the more a difference it makes. So if you were to invest for a longer period of time, the compound interest is better. Now, working with example 3, we're going to work out a present value. So let's say now we're going to look at it from the other end, that our goal is to have $2,000 in 5 years. So we have a goal to save. You can get 10%, so how much should you start with? So in other words, we know the future value this time, and we want to work backwards to find out what the present value is. What am I working with so that in the future I will have the money that I want? We know that multiplying a present value by 1 plus the rate to an exponent gives us the future value. So we can go backwards by dividing. So here you can see going forward, we are timesing by 1 plus the rate to the exponent. So it makes sense that we would want to divide or go backwards. So here's the formula that you see underneath for present value. So in order to find that out, we are going to take our future value, which they said they want us to have $2,000 in 5 years. We're going to do 1 plus the rate. So 1 plus, our rate is 10%. So 10% as a decimal is going to be 0.1, and we're going to raise that to the time of 5 years. The calculator will do all the rest for you, and you get a present value of $1,241.84. In our last example, compounding period. Compound interest is not always calculated per year. It could be per month, per day, etc. But if it's not per year, it should say so. So know that. If it doesn't state, it automatically defaults to year. So let's look at this. You take out a $1,000 loan for 12 months and it says 1% per month. How much do you pay back after a year? Okay, well, think about that. A year is a full 12 months. So your present value would be that $1,000 times 1 plus your rate, but you're not going to do 1 for 1 year. You would do 12 because you're going to do that for 12 months. So that ends up being a present value of, if you multiply that out, $1,126.83. So just know you can use this formula in different ways going forward and going backward, and make sure you definitely understand this general setup from the previous page. That is going to be the formula that you want to use for these types of problems. And that concludes your lesson on simple versus compound interest.